Research review. This is beta version of this research, but man, number one, is it good, and is it long? Um, so I think I'm doing the RR on this version. So I haven't done an RR in a minute, so I'll need to figure out how to do that. But it's worth figuring out here. So this is by xssdoctor. Yes. So this is a very deep dive into framework-specific CSPT problems. So when you define client-side routes for a framework, how it handles decoding, it's a big piece of this. I'm just going to get into it. There's a lot of stuff here that is going to be so valuable to reference, just to look at for, oh man. And honestly, like, building some like AI summary here might be useful as well for like building a Claude skill for, oh, I don't want to think about that. Okay. The ... that frameworks hand you. Client-side path traversal across every major front-end framework. How I mapped the decoding pipelines of 8 front-end frameworks and found that every single one gives attackers traversal primitives. Client-side path traversal, CSPT, is my favorite gadget. It's a client-side attack primitive that lets you bypass front-end route guards and control the location of the API call. It is a great primitive for CSRF. When chained with open redirect or a file upload bug, it can easily lead to XSS. When it works, it feels like magic. When I first discovered this bug class, I became obsessed with it. I tested for it everywhere I could, even if I didn't understand the framework of the backend. My testing strategy was to find a path that appeared to be dynamic, like /user/xssdoctor, and add %2f, %5c, double encoded, etc. I would then look at the API calls and see if the encoded slash or backslash was decoded into a path traversal primitive. I would iterate on that with a ... and so on. But when it came time to do dynamic analysis and try to figure out how it really worked, I had trouble. What exactly was the CSPT source? How was that dynamic path referenced? Why were the paths sometimes URL decoded and other times not? I got far with this off-the-cuff testing, but I wanted to understand the root cause, so I set out to map the URL decoding pipelines for every major front-end framework. I wanted to see exactly where and how the traversal primitive was being created. After spending weeks reading router source code, building lab apps, testing encodings and cross-referencing GitHub issues across React Router, Next.js, Vue Router, Angular, Svelte, Kit, Nuxt, Ember, and SolidStart, I can tell you this. The problem is universal, but the exploitation is framework-specific. Let me walk you through what I found. Okay, so some big things here. Yeah, when I watch the doc hack, it makes me sad sometimes how, like, there's moments where I'm like, I would immediately just start diving into the debug rabbit hole for this, but he's just like balls. And it works really well. And so to see that, like, he's answering the real questions, that it's like, yeah, I don't know, man. That's like an implementation detail. This is good. This is very good. I'm very excited for this research, and it is, let's just say the doctors prescribed us a very large dose here, and there's a lot. So getting back to it, some things to understand. Let's start with the browser. Modern browsers will normalize path traversal payloads when a path with a ... in it is entered into the address bar. The browser will resolve the ... before sending the request to the server. So the request that hits the wire is actually /second. This is part of the URL specification and not something that frameworks or servers can change. However, URL encoding can be used to bypass this normalization. For example, with the ... encoded, will be sent to the server as is, and the browser will not resolve the ... because it is encoded. / will be normalized to / in the browser. Target.com/path will be normalized to /path. This is not the case in query parameters. If you have a URL like q equals, the ... admin is part of the query string and the browser does not normalize it. It will be sent to the server as with the ... This is an important distinction because it means that path traversal payloads can be used in query parameters without worrying about browser normalization, while in the path itself you need to use encoding tricks to bypass the normalization. Yeah, I'm very glad that the doctor added these pieces to this. I reviewed an earlier draft partially, and this is such helpful context to establish kind of where the delineation between browser behavior and then framework-specific behavior is. Now let's talk about front-end frameworks. In multi-page applications, the URL path maps directly to a file on the server. So if you have a URL like target.com/admin, the server will look for a file called admin.php or .html and serve it. In single-page applications built with front-end frameworks, the URL path is handled by the front-end router. This router takes the URL from the browser, extracts the route parameters, and hands them to developer code. That's my favorite code, by the way, to hack is developer code, because developers always like mess things up. Alright, sorry. The backend of these frameworks is often an API. The frontend makes fetch requests to the API and populates the page with a response. The frontend router is responsible for taking the URL, extracting parameters, and then those parameters are often used in API calls. If the router decodes the URL in a way that creates a traversal primitive, then the primitive can be used in the API call. There's a really interesting piece here, I think, with SSR and the way some SSR apps are implemented, where you actually might be able to get server-side path traversal, what are the Sam Curry secondary path traversal, whatever the popular language used there is. I feel like there's a lot of potential for exploring how SSR can cause problems in certain cases, especially with the way a lot of these silly Next.js, at least I've seen, APIs are implemented that effectively act as... Alright, not relevant to this though. Sorry. Client-side path traversal occurs when the front-end router uses an element of the path directly and passes it into the fetch request. The question is, when does decoding happen? What gets decoded, and does it ever get re-encoded? The sources that we have to focus on itself, /path, group, parameters, and hash fragment, are the... Okay, each of these can be decoded differently by the framework, and each has different implications for path traversal. The sink is the API request, usually a fetch call. When a path traversal payload is passed into a fetch on the client side, it leads to client-side path traversal. When a path traversal is passed into fetch on the server side, here we go, it can lead to an even more dangerous scenario of secondary path traversal, potentially allowing access to internal resources. Yeah, there's definitely... Oh, man. Encoded path traversal payloads may be normalized on the front or the back end. For example, sending /path.%2f may be decoded with the .dat by the front-end router, and then the browser will normalize to /admin before sending the request. Alternatively, the front-end router may pass the encoded value to the back end, which then decodes it and normalizes it. The exact behavior depends on the framework's URL decoding pipeline. So I built lab apps, compiled them, read the minified output, traced the decoding functions, and tested every encoding variant I could think of. Here's the framework by framework breakdown. Wow, yeah, again, this is, oh, man. Oh, and it's, this, I mean, yeah, this is really good. This is really good. Paths. Hold on, I should... I'm missing an apostrophe. Paths. Let's start with the path itself. Specifically, let us think about how these frameworks handle dynamic path segments like /users, user ID. When you navigate to /users, %.2f, does the... or %2f. Does user ID become ./admin, or does it say %2f admin? Does it become something else entirely? Front-end routers. React, Vue, Angular, Ember, and Solid are primarily front-end frameworks, so the routers run in the browser. What about SSR? Sorry. Each use unique pipelines to parse these dynamic paths and allow the developer to reference them later. Okay. Actually, I have to pause and check on Claude. React. React Router has the most well-documented decoding pipeline. Paths are handled through the useParams function. Why is that big F? When I see big F function, I get really excited. And so, on the client side, here's the pipeline. Browser URL, %encoded, decode path, per segment, decode URI component, then re-encode / back to %2f, compile path, builds regex for route matching, match path, extracts param values, use params, returns fully decoded params. Oh man, I'm getting excited again. This is attack surface, by the way, especially when they define crazy routes, and especially when the matching is performed server side. You can lead to redos, which is actually really, I should explore this deeper and do a write up on it, but I've got more important things to do. Somebody can do that. Somebody will do that. Slept on bug class of like client side routing caused redos bugs due to questionable route generation tactics. Decode path in line 863 is explicitly an anti-CSPT defense. It decodes each segment and then re-encodes any slashes that appeared. This prevents %2f from creating new path segments during route matching. Then match path on line 811 undoes it. So it replaces any %2fs with slashes. So /users / some encoded traversals would result in ../admin. In other words, when the developer requests the dynamic path, the path is already URL decoded with slashes intact. If they interpolate that into a fetch URL, the traversal lands, GG, and we get CSPT. Yippee. React Router also had a documented double decode bug that the pipeline ran 2 separate decode stages, safely decode URI and match routes, then safely decode URI component and match path. So %252f would decode into %2f in the first stage, then to slash in the second. Double encoding bypass built into the framework's architecture. Sentence? They fixed it, sort of. Standardized on safely decode URI component throughout. Huh? Sentence? They fixed it sort of by standardizing on. But the current what are these sentences? But the current pipeline still double decodes through a different mechanism. Decode path runs decode URI component, producing. Then line 811's converts that to slash instead of 2 calls. You know in like Monty Python and the Quest for the Holy Grail where they like reference a scene, like I forget what scene number. It's like scene 24 or like act whatever, and they like reference a scene number by name. Where it's like it's a really funny gag, but like this is conceptually the same. It's like yes, line 811. Yeah, obviously line 811. It's like I don't know what you're talking about. But I believe I blame AI. Instead of 2 calls to decode URI component, we now have decode plus string replace. Same outcome, %252f becomes slash in your params. The fundamental design hasn't changed. Params are fully decoded before your... Why did this suddenly switch to mine? This isn't my string. I don't really want it. Or my code. Because developers expect use params to return human-readable strings, not URL encoded gibberish. The overlong UTF-8 and Unicode homoglyph bypasses don't work. Very true. Oh yeah, with this table. This table basically says you can have a whole lot of fun. And that things work intuitively. As far as like, I wish this worked, and then it works. If your intuition is that like the application is gonna let you party, then you know, cause like, application is gonna let me party. That's my intuition. So splat routes are fun. But right, so yeah, no Unicode normalization. I mean, yeah, obviously. You know, it's a JavaScript world, and fortunately that doesn't go on there. Splat routes, path equals file slash are the most dangerous variant. Params captures slash boundaries with /regex instead of used for name params, so works with no encoding tricks. The browser will normalize the URL and resolve it, but the traversal primitive is right there in the param value. Yeah, these are also dangerous, I think, for when it generates the regular expressions, and if you've got weird stuff and it's trying to match which one, you might get redos, I don't know. Further research required there. Angular, which versions of Angular? Latest Angular? I don't even know how to use modern Angular. I only know how to hack old Angular. Angular's URL processing uses segment regular expression equals to match path segments. This treats %2f as 3 characters, %2f, none of which are in the exclusion set. So %2f stays in a single segment during route matching, but then decode runs decode URI component on each segment after the matching stage before the value reaches param map. Wow, this has got to be really nice to have like looked at modern Angular. Param map.get user ID. Okay, yeah, so that's like how code would work. I tested this on Angular 21.2.1 in Chrome. URL /encoding whatever gave params. There we go. Decoded the slash. Nice. With the traversal, gave a traversal. This makes Angular more exploitable for %2f based CSPT than React Router or Vue Router for regular dynamic params. In those frameworks, %2f can sometimes break route matching and return a 404. In Angular, the route matches and the developer gets the decoded slash. The param flows straight through to HTTP client. Nice, I like that. Angular also has a non-obvious encoding behavior in router.navigate that creates a differential between direct URL visits and programmatic navigation. Very funny. Man, I don't like history routers. They make me mad. I like hash routers. I don't like history routers. Like as a developer. You know what? I'm not even a developer. When you pass a value containing % to router navigate, Angular's encode URI segment re-encodes it. So router navigate / path, comma, that produces in the URL bar. This creates a trap. A developer might reason, I got .. /.. from query param map. I'll pass it to router.navigate to redirect the user. But router.navigate encodes the value as a path segment, turning to .. / instead of in the URL. The traversal doesn't happen through navigate, it happens at the HTTP client sink, where the decoded query param is interpolated directly into a fetch URL before any re-encoding occurs. But router.navigate redirect, where redirect comes from a decoded query param map, does let an attacker control navigation. That's an open redirect. Interesting. Well, is it, how open is it? I like to, I don't, this isn't real nomenclature, but in my opinion, if I can go off target origin, it's an open redirect. If I can go on target origin, just redirecting on origin, I call that a closed redirect because it's closed to the, but I don't think that's real nomenclature, and I think I made it up, and I think it might offend people. Some people get, you know what, I'm a poet. I got poetic license. I can make up whatever I want. So I like to use that nomenclature because it's cooler. Now, if you could get an absolute URL in there, then maybe you could get an open redirect, but I think that's a closed redirect, but I also don't stand on, The ** wildcard route deserves a note. Unlike React Router Splat *, Angular's wildcard does not capture subpaths in a name param. Developers must use router.url, which preserves encoding, or manually parse the URL, which usually means calling decode URI component themselves. The wildcard is architecturally safer than React Splat for CSPT, but manual URL parsing immediately reintroduces the vulnerability. Yeah, I feel like anytime there's like manual URL parsing, that should be a hotspot for code review, just because like they're probably up to no good if they're going off of the rails of the framework. All right, Vue Router v4 is the framework I'd prioritize if I'm hunting for CSPT on a target. Vue Router maintains 2 views, of every URL, and they have opposite encoding. So there's the route.params by like named, decoded, whatever, and then there's just the path, which is encoded, which makes sense. This isn't a bug, it's a documented design decision. The Vue Router maintainers confirmed in an issue that slashes are URL separators and must be encoded, but %2f in params arrives decoded because route.params runs through decode params, which applies decode URI component. There's also a router.push encoding asymmetry that creates confusion. With a string path, the input is passed through parse URL as is, so router.push navigates with literal .. and the browser resolves the traversal. But with the params object, Vue auto encodes via encode params, so router push name params encodes to with things encoded, which is safe at the navigation level, but then still decodes back to .. /admin and route params. Catch all routes, those look fun. Return an array, interesting. But the split behavior is important. Only literal characters create array splits, so if you use %2f, it decodes to / inside a single array element, not a separator. So /files gives path match equals 1 element, while files with decoded slashes gives path match 3 elements. Either way, .join / produces the same traversal string. That's cool. Ember. Oh man, I like Ember because it's a fun toy. Ember's decoding pipeline has a key intermediate step that no other framework uses. Normalize path. Before route matching, every URL segment runs through this function. Interesting. So we've got some function that splits on /, calls normalize segment on everything, which tries to potentially decode it and then replace certain, okay, and then URI encodes certain values, and then rejoin with /. The splits on / applies decode URI component to each segment and then re-encodes only %2f and / back. So %2e becomes .. and stays as .. but %2f encoded / becomes / and gets re-encoded to %2f. The normalization preserves dots and neutralizes slashes for the purpose of route matching. Yo, looks like you can get backslashes through there, right? Or like encoded backslashes. Then comes find handler, which extracts the matched groups for dynamic : param segment. It applies decode URI component again. For * param segments, it skips the final decode. This creates two completely different exploitation profiles. Route recognizer. It's a fun name. And so that's like looking at things and knowing about things. I love when the code does that. Should decodes J is true for dynamic segments, false for star segments, two segment types, two decoding behaviors in the same function. For dynamic param routes, here's the trace, url/users/.%2f admin, normalized path splits on slash, normalized segment, decode URI component, re-encode %, okay, yeah. Reassembled, regex match, no literal slash find handler decodes, params.userid equals ... /admin. The traversal payload is delivered, and %2e, %2e, %2f works identically because normalized path decodes to ... and the slash gets re-encoded, producing the same ... %2f intermediate form. Double encoding does not work in Ember. Here's why. %252f decodes to %2f during normalization, but the % in 2f gets re-encoded back to %25 by the replace step, producing %252f again. Segment is back to its original form. Find handler then decodes %2f to a literal string, not a slash. The normalized path function's re-encoding actually prevents the double decode attack that works in React Router. This is an accidental defense. The same re-encoding that preserves slashes also preserves the % character, making the normalization idempotent for double encoded values. For wildcard param routes, the picture is different. The regex captures everything, including literal slash. So docs slash ... blah blah blah. And params .doc path gets with no encoding tricks needed. But since star segments skip the final decode URI component %2f in a wildcard stays encoded in the param value, the effective payload for wildcard routes is literal ... slash not %2f. Okay. Huh. And then we have a table for star versus dynamic, and if we can traverse and what behaves. And again, we don't have overlong good behavior because, again, decode URI component is like, dude, no, I'm not dealing with those. And it doesn't do anything fun, which, it's good. You shouldn't do anything fun, especially if you're JavaScript. Or maybe you should. SolidStart. I don't actually know about SolidStart. SolidStart is one framework that got this right by accident, not because the team built anti-CSPT defenses, not because they analyzed the attack surface, but because @solidjs/router simply never calls decode URI component on route params. The router's create matcher stores raw URL segments as is, and that one missing function call makes it the most resistant framework to encoded path traversals I tested. The create matcher function splits location.pathname on slash and stores each segment directly in the params object, so it's just boring. Navigating to with encoded traversal returns and params.userid returns encoded. The %2f is still %2f. The dots are still encoded. If you encoded them, nothing has been decoded. If the developer interpolates that into a fetch URL, the browser sends the encoded string to the server, which sees %2f, not slash, no traversal. I verified this in Chrome with a SolidStart lab app, which gave that. The dots decoded, browsers decoded %2e, and the path name of the slash stayed encoded. That's the critical difference between React Router, where both dots and slash are decoded. So yes, no, and I think that this is the reality then is if you are a developer using this and you might have weird characters in some path route, you are likely to regularly just have a pattern of adding your own decode URI or decode URI component calls after reading params.whatever, because you might have a colon in them, I don't know, some characters in them. So you might still have things that are vulnerable to this just because the developer got into the pattern of calling decode URI component at the end with the decoded thing because they wanted it. Okay, there are only 2 decode URI / component calls in the entire SolidJS router codebase. One is the A component for active link CSS class matching, the other is for scroll to hash. Neither is in the routing or param extraction pipeline. Catch-all routes are the exception. The catch-all captures remaining segments joined with slash lock segments.slice. These slashes are real, but they come from the URL path itself. Navigating to /file/a/b/c and params.path equals abc Here's the thing, literal .. slash and the URL get resolved by the browser before JavaScript sees it, yeah. So throwing a traversal there wouldn't work, unless, unless you could throw some character in there that it strips magically. Route won't even match the /file/star path as encoded. Okay, it stays encoded in the join string, so the catch-all gives you as a single segment, not a traversal, yeah. And then, obviously, you can't have fun with those. Well, you could, if the custom decoding logic implemented by the developer after wanting a decoded version didn't use decode URI component and instead used super silly decode component with Unicode wrapping .js, but that's not real. This is fundamentally different encoding posture than every other framework. React Router, Vue Router, Angular, and Ember all decode params before your code sees them. SolidStart doesn't. Alright, I'm going to pause and check on Claude. Okay. Hybrid cases, right. I think this is where we were. Next.js, Nuxt, and SvelteKit are hybrid frameworks. It's missing the dot. That run code on both the client and the server. This creates multiple decoding contexts, my favorite, which can lead to unexpected vulnerabilities if you're not careful. Next.js. First thing to understand about Next.js is that routing starts out on the server. Well, it depends if you do a fully client-side build versus a Next server, but like there's a difference. You can do like, alright, man, I gotta not argue with the text. Actually, I've got to argue with the text. That's why I'm here. I'm here to argue with the text. That's the whole value. What do you mean? Well, I'm not an audiobook reader. I'm here to argue with the text. It's a lot of words. Okay, so yes, my problem with this is you've got to look at Next pure client-side builds, which I think are getting a lot less popular, actually. Because you can just build a Next app as a purely client-side thing instead of the default server-side rendering, and then that way you don't have to run the stupid Next server, and you can just throw it on a CDN and host it like a React app. So, yeah. What? But, does that... I don't know how that behaves. Hey, is that documented here? No? Okay. Well, maybe we'll get there. It's a long... We're not even halfway in. Alright, I'll be nice. When you navigate to a URL, the server matches it to a page component, runs get server-side props if it exists, and sends the rendered HTML to the client. The client then hydrates that HTML and takes over routing for subsequent navigations. This means initial URL parsing and param extraction happens on the server, not the browser. Next.js has two separate routing systems, the app router and the page router. The app router is the new system that uses React server components and file-based routing. The pages router is the older system. Oh, Lord. Both have their own decoding pipelines, but the app router is where the interesting behavior lives. More on that later. Might be a little too interesting. Next.js app router has a function called getParamValue in... That's a strange dist shared lib? Come on, man. Can I see the original TypeScript? No. That reencodes parameters before passing them to a page and layout components. If you navigate to /file/path %2f booyah, a page component gets the path %2f booyah back. The slash is reencoded, traversal is neutralized. On the client side, use params behaves the same way, reencoded safe. Nuxt is built on Vue Router, so I expected the client side behavior to be identical. It is. What makes Nuxt interesting... Why is this in the Next.js section? Can we have a different section for Nuxt? Can I have like another header here? Alright. What makes Nuxt interesting is everything that happens around Vue Router, the server-side H3 layer, the island component system, and the split personality between client and server param decoding. On the client side, Nuxt inherits Vue Router's decoding pipeline exactly. useRoute.params values pass through Vue Router's decode params, which applies decode URI component to every matched parameter. Navigate to /user/%. Wow, and route params IDs returns decoded. The slashes are real. The dots are real. Everything I have described in the Vue Router section applies here without modification. The server side is a different story. Okay. Nuxt server routes run on H3/Nitro. Man, come on, man. Which has its own param extraction via radix3. Dude, we're just making up words at this point. The critical function is getRouterParam. So there's the H3 code. So it looks like it's doing some stuff and having fun. Get router param event ID does not decode by default. The decode option must be explicitly passed as decode true. Without it, %2f stays as %2f. This is genuinely safer than Vue Router's client-side behavior where decoding is unconditional. But the safety is opt-out fragile. The moment a developer writes get router param event ID decode true or manually calls decode URI component on the raw param, the traversal is live, and H3's own documentation shows examples of the decode option enabled. Yeah, and again, that's something, even if the framework doesn't decode things, you can expect that the developer might, because there's a colon in it, I don't know, or like some other character that gets encoded. I'm not sure. Need to think of what the most interesting or most likely character for that would be, but catch all routes pages. I mean, it just takes one bug to be filed where it had a crazy character in it that was URI encoded, and they'll just add a decode URI component to fix it. An AI bot would do it. All right, sorry. Catch all routes pages files whatever. The slug.vue compiles to Vue Router's pattern on the client, and radix3's wildcard on the server. On the client, catch all params return an array of decoded segments. Joining that array with / produces nice, cool traversal. On the server, event.context.params._. It'd be funny if it was Lodash. Or event.con. I love the idea of like having Lodash built into all your params instances in case you need it. It's like it's like, all right, nope, all right, I need a real, all right. Or event.context.params.path returns the raw matched path string without decoding. Yes. Sorry, I'm just having too much fun with my own. That's a Svelte. SvelteKit decodes params through a two-stage pipeline, and unlike Next.js, there is no re-encoding before your code sees them. The result is that %2f in a URL path becomes a real slash in your params. Oh man, that guy's a real slash in my params. This makes SvelteKit exploitable from path params, more like React Router and Vue Router than Next.js. The decoding chain has two stages. Browser URL, %encoded. Decode path name splits on %25. Applies decode URI per segment. Route regex match. Okay, they're having fun. Decode params. Applies decode URI for each param value. Params.userID. Fully decoded slashes are real. Better than fake ones. Or like Unicode weird ones that aren't slashes. The key is the two-stage decode. Decode path name uses decode URI, which does not decode fun characters, but it does decode dot, so I guess that's fun character. So %2f stays as %2f during route matching. The regex sees three literal characters, %2f, not a slash. The route matches them, then decode params runs decode URI component, and it becomes slash. By the time the developer's code sees the param, the slash is real. Navigate to whatever, and params.userID returns ... /admin/secrets. If the developer interpolates that into a fetch, yay. This is true CSPT. Traversal happens at the fetch layer, not on the server. On the client-side navigation, the browser's native fetch resolves the ... before sending the request. On initial page load, SSR SvelteKit server-side enhanced fetch resolves it internally, either way the traversal lands. How does the server-side enhanced fetch work? Huh? Okay, again, this is, your SSR and SSRF both start with SSR. That's a fact that the framework gods don't want you to know. So, actually, I mean, I'm surprised, honestly, that no, like, I guess there wasn't really too much deep dives into server-side behavior here, but I'm just surprised there weren't, like, SSRF bugs found. I don't know. That's the kind of thing where you really just have to have like a debugger attached to the node process for the server-side component and figure out what's going on, and I don't know if that was where the focus of this testing was. Can I just say this research is crazy? Like, this is exactly what I was looking for. Like, okay. The one area where SvelteKit is genuinely more secure than React Router is double encoding. Decode path name splits on %25, encoding % before decoding, which prevents double encoding. Here's the trace. Okay, it just kills them, and it rejoins with them. Okay. React Router pipeline converts %25 2f to slash. through its decode then replace mechanism, where SvelteKit splits on that. To fix a specifically documented double decode bug. There we go, and it got fixed. Catch-all routes have a unique quirk in SvelteKit. They return a string, not an array. Interesting. Which gives that. Vue Router returns that. The string form means no dot join slash is needed. Okay. Traversal sequences work natively when interpolated into fetch URLs. Interesting. Okay, query parameters. Yeah, I like query parameters are more likely to be free, because the correct behavior for query parameters is to URI decode them when you parse them, right, and you don't even need to, right, because you don't have to encode them. But anyway, query parameters are a rich CSPT attack surface that often gets overlooked. Really? They don't have the same. When I think of like Baby's first CSPT, I would think via query parameter, just because you don't need to think about decoding. You just throw the literal // in there. Interesting. Also, should that be capital? Okay, I guess I read that wrong. They don't have the same segment boundary protections as path params, and many frameworks decode them fully before your code sees them. Query params have a bigger attack surface than path params because there's no segment splitting. The entire value arrives as one decoded string, and since query params don't trigger browser path normalization, you can use // without any encoding at all, and backslashes without any normalization. However, encoding may help with... We got WAF with 2 Fs, and one of them is for like fraud, I guess, or other filters that look for traversal patterns. React. Use search params returns decoded values. True. The browser handles... Thank you. Because, I feel like people aren't even thinking... you've got people hacking on these React apps not even thinking about use search params, and it's like, how are you going to hack on a React app and not think about use search params? So, honestly, man, I feel like this research really, must have been, really good for, leveling up. Oh, man, the doctor's going to find so many cool bugs. The browser handles the decoding before JavaScript sees the value, so widget equals nice, gives you decoded. There's no re-encoding, no sanitization, nothing between the decoded value and your code. Yeah. Group parameters are actually a bigger attack surface than path params for one reason. There's no segment boundary. Yep, as mentioned previously. With path params, the router splits on slash first, so your payload has to survive inside a single segment. True. With query params, there's no splitting at all. Well, so yeah, lands as one decoded string. You don't need any encoding tricks because the browser doesn't normalize it the same way it would for paths. I'm going to pause. Next.js. Use search params on the client side returns decoded values. Navigate to /dashboard/stats widget equals with traversal. And search params.get widget returns traversal /is a real dots are real. This is one area where Next.js page components are vulnerable to a client-side CSPT. The path param reencoding defense only applies to path params accessed through await params or use params. Query params go through the browser standard URL search params, which decodes everything. Yep. If a developer reads a query parameter and interpolates it into a fetch URL, the traversal works exactly the same as in React Router. Yep. View. Route.query is decoded in the same way as route.params. Navigate to /dashboard/stats with an encoded traversal, and it gets decoded. Don't even know why you need to decode it, man. I guess WAFs maybe. Angular, but without a capital A, because we don't like Angular. Query parameters are an even bigger CSPT surface in Angular than path params. The router decodes them via decode query, which replaces plus with %20, then calls decode URI component. Interesting. Query values are matched by fun. They stop at and or hash, but not slash, so without yep, works fine. This is significant because path params at least have the segment matching stage as a gate. Angular splits on literal slash first, so your payload has to survive a single segment. Query params have no such constraint. The entire lands in as one decoded string slashes and all. Okay. Svelte. URL.search params and SvelteKit load functions is standard. What? URL.search params and SvelteKit load functions is standard URL search params. Oh, okay. Which means it decodes everything. That's like that's like a capital U URL, which has a .search params field. Yeah, okay. Widget equals gives you decoded on the client side $page URL.search params. But okay, so that's another big URL object that has its .search params field, which is an instance of URL search params. Behaves the same way. Decoded slashes are real, no segment boundary constraints. That's not a sentence. What? Can we have sentences? Please? And since query params don't trigger browser path normalization, literal // works without encoding. Next, use route.query on the client side is decoded by Vue Router's parse query. Navigate to and route query.widget returns decoded. Same as standalone Vue Router. One quirk, plus, is not converted to a space. Vue Router treats plus as a literal character, unlike standard URL search params behavior. On the server side, H3's getQuery event uses the UFO library. What is going on with that ecosystem? Which does decode query values, so becomes widget // on both client and server side. Query params are decoded everywhere in Nuxt, which again is spec, like that's how they're supposed to be treated. Ember. Query params and Ember are declared on the route or controller via the query params property. Yeah, it's so weird. They arrive in modeled params hook alongside path params. Route recognizer strips the query string before route matching and parses it separately. Values are decoded by the browser standard query parsing. Navigate to period equals and params.period returns. The traversal is in the decoded value, but what if it had been encoded? Like every other framework, query params have no segment boundary constraints, so the full traversal string lands as one value. Like, yes, this is true, but what about the encoded version? Because like we were looking at the encoded version for all these other ones. Why are we looking at just a normal when you set the query parameter to something not encoded, doesn't magically encode it. SolidStart. Use search params returns values decoded by the browser standard URL search params, which calls decode URI component. I almost want to like pull up the Chromium source and see like how does it call this under the hood, and if so, how? Like look at the torque code or whatever for this. Is that, I don't even know if that's real. Navigate to /dashboard/stats source equals and search params.source returns. Yup, the slashes are real. Yes, they're real. They're not fake. I still a gallery of fake slashes at the end of the write-up. This is the primary CSPT vector in SolidStart. Path params are safe because the router doesn't decode them. Query params are decoded because the browser API does it, and the router can't prevent that. The attack surface shifts entirely from paths to query strings. Yeah. Yes. Yes. Hash. Okay, we've entered the cool guy zone. Window.location.hash is the simplest source. Browser never encodes or decodes the hash fragment. I'm gonna pause and get back to you on this. Whatever you put after the hash is exactly what JavaScript sees. Navigate to /hash whatever, and window.location.hash.slice1 gives you with no encoding. That's unfortunately the sentence, the browser never encodes or decodes the hash fragment, is simply not true. So there are characters that will encode. So if you do like location.hash equals single quote left brace or left angled bracket h1 high close h1 tag and set that to the location.hash, and then you grab location.hash, you're going to get %22 %3c h1 %3e high %3c /h1. So it's not encoding like slashes, and I don't think it encodes dots. Why would it do that? Yeah, but it is encoding certain characters, so that statement's just not true. I think there was a time where there was different behavior here in some browsers, and people actually used it for fun. But this is a behavior that really matters for like reflected, for some like DOM XSS scenarios that write the like location.href or whatever to the DOM. You can't get HTML elements through it, so there is some encoding. So I just feel like that should be stated because while it isn't interacting with these characters, it's interacting with that one. It's interacting with that one and some other ones, so be careful what you believe, because you might get tricked into thinking you can get some DOM XSS when it's doing something silly with a URL. Alright, yeah, so yeah. Yes, the hash is fun. And in this case, yes, this is all true. It won't mess with these characters. The sync. When we talk about the sync, we're usually talking about fetch, but it could be any function that takes a URL or path and makes a request. The key point is that if the decoded value from the URL gets interpolated directly into the fetch URL, the browser will resolve any ... sequences before sending the request. This is true for both client-side navigation and server-side rendering contexts. If a path traversal payload reaches client-side fetch, this leads to CSPT. If it reaches server-side fetch, it can lead to secondary context path traversal. And again, weaponizing these with like framework-specific gadgets would be such cool additional research, but it's so beyond the scope of this excellent write-up. React. The sync in React Router apps is almost always fetch or a library wrapper around it like Axios. Yup, I sign off on that. The decoded param gets... what if it was jQuery? Alright, sorry. Which calls... Alright, nope, we're not thinking about things. Decoded param gets interpolated into a template literal, and the browser resolves ... before sending the request. The most dangerous combination is when the fetch response flows into dangerously set inner HTML. This turns CSPT into XSS. If the attacker can control what endpoint the fetch hits and the endpoint returns HTML, then the HTML gets rendered directly into the DOM. Navigate to that, and it fetches that, and you get fun, controlled response, and you've got XSS through CSPT. The only safe source in React Router is useLocation.pathname, which preserves %2f encoding, everything else decodes. Yeah, and this doesn't talk about the cool scenario where it gets some JSON back from the response and then spreads it onto an object with no children, and so you can bring your own, but you should go look at my write-up on my challenge lab that I wrote for whatever about that or something. I don't know. I know xssdoctor enjoyed that challenge, and when I was writing it, I knew how much fun he'd have with it, and so it's really good to see this because this is like the fact world. This is CSPT fact world. Like, I love that. Next.js, unlike getParam value, await params has split behavior depending on where you call it. Page components, layout components, and use params all go through getParam value, which reencodes route handler. Skip that function entirely. And a route handler await params receives decoded values directly from getRoute matcher, which does match.split/map decode. The framework uses... What about backslashes? What about backslashes? The framework uses the same API in both contexts, but applies completely different encoding behaviors under the hood. Could you introduce backslashes this way? By decoding encoded ones. The same API name, two opposite behaviors. Page server component, yeah. Route handler, ooh. Use params, client side, yeah. Why does this matter? Because the common Next.js pattern in a page is a page component that reads params and passes them to a client component, which fetches to a route handler. The page component does nothing wrong. It doesn't decode anything, but the re-encoded %2f in the fetch URL gets sent to the route handler, and the route handler's await params decodes it automatically before the developer's code even touches it. The developer never opted into decoding. That's just how route handler param passing works. Interesting. Here's the attack chain. Navigates to /CSPT await params. Docs getting started with a little bit of fun going on. Personally, I would have used %5s from 5Cs for more flair / likelihood to work. But that's a dubiously black box approach. Page server component reads await params. Look at that. It's, they're having fun. Page joins and passes to the client component. Client component fetches. Ooh. Browser sends with the encoding. Route handler reads it, but then the route handler's gonna decode it, I guess. And then the route handler joins it. Okay, and now it's traversing server side, but oh lord. Yeah. This is not a client-side path traversal. This is a secondary context path traversal. The encoded path is sent to the server, which decodes it and passes the decoded value into a backend fetch. This is potentially more impactful because the server often has access to internal resources that the client does not. The router handler is fetching from an internal API or reading from the file system. This traversal primitive could reach sensitive data, so true. Yeah, that's fun. Yep. Hey, what's even more fun is if there's no slash there and you can try to figure out, like, alright, we're not getting an and through that, never mind, or an at. Or, oh lord, or dots. Okay, yeah. Maybe we are. I just want SSRF. Can I just have SSRF? Vue Router. The result is the most exploitable param to fetch pipeline of any framework. So there you go. You've got, use fetch. What is that? Yeah, I know that. No, I don't. I've written some Vue in my day. The most dangerous pattern is when fetched response flows into VHTML, which is Vue's equivalent of React's dangerously set inner HTML. This turns CSPT into XSS, so yeah, you're grabbing something, but lol, you got traversed, and oh no, it grabbed the funny zone, a fun provided JSON, and that funny JSON is getting passed into the DOM, and now you're having fun because you have HTML injection. So there we go. Yeah, so it hits that and grabs the attacker uploaded file and reads it and has fun with it and renders the HTML. And script execution optional. We'll see how the CSP is. The only safe resources in Vue Router are route.path and route.fullPath, which preserve %2f encoding. Everything else decodes. Angular. The sync in Angular apps is http client.get or .post put. The decode param gets interpolated into the URL string and the browser resolves the // before sending the request. The most dangerous combination is when the HTTP client response flows into inner HTML with bypass security trust HTML. Angular sanitizes inner HTML by default, but bypass security trust HTML explicitly disables that protection. This is Angular's equivalent of React's dangerously set inner HTML, and it turns CSPT into XSS the same way. Yeah, I don't know modern Angular, but looks like there's different ways to read params, and here's how they do things. And look at that. Can we dump into... Oh yeah, we're... Yeah. Okay, so yeah, this is fun. Is that open? Okay. Only safe Angular source for URL derived values is router.url. I don't like this because that's not where the fix needs to be prescribed. Like, I've read this decoded parameter, but before I pass it into one of these syncs, I need to make sure that it doesn't perform anything crazy. Like, essentially, I need to almost like encode the parameter before making the web request, and I need to make sure that the server is not decoding things, as we saw earlier. Man, developers. SvelteKit. On client-side navigation, the browser's native fetch resolves the // before sending the request. I want more backslashes. Can we get some backslashes in here? Can we get some reverse solidus? On the initial page load, SSR SvelteKit server-side enhanced fetch resolves it internally. But the real escalation in SvelteKit is plus page.server.ts. Why are we naming things this? What's going on in Svelte? I've not used Svelte, so why can't we just write HTML and vanilla JavaScript? I like React, because it's bad. Server-only load functions execute with internal network access and can reach services the client cannot. Yeah. This is a secondary context path traversal analogous to Next.js route handlers. The fetch goes directly to the internal service. It does not pass through hooks.server.ts, so even if you have auth middleware in your hooks, ooh, that's nice. A traversal from a server load function bypasses it entirely. That is very cool. The most dangerous client-side combination is when the response flows into, Svelte, which is Svelte's equivalent of dangerously set inner HTML CSPT plus funny HTML template equals XSS, same as in React and Vue. And then look at that, we're having so much fun. SvelteKit's param matcher defense is the best I've seen in any framework. So, yeah. If the param doesn't match the pattern, the entire route fails to match. Traversal payloads get rejected at the routing level before any load function executes. It's opt-in, not default, but when used, it's the strongest framework level defense available. No other framework offers route level param validation that prevents the load function from even running. That is interesting. And yeah, that's a sad character set. If I was limited to that character set in real life, I don't know how much I would have to say. Next, the primary client-side sync is useFetch and $fetch or money fetch or get money. Next, data fetching composable, pass the URL string directly into global this.moneyFetch with zero sanitization. So that's cool of it. Actually, I need to check on Claude. The standard CSPT pattern, so there we go. It's using useRoute, it's grabbing that route.params.id for useFetch, getting some data back. Multi-param routes double the attack surface, so that gives that, and then if you do that, then you get to have even more fun. The server-side sync is where Nux diverges from standalone Vue server routes under server API, execute with full network access, and can reach internal services. The common proxy pattern is the most dangerous. Yeah, so many, man, developers just do this, man. Yeah. Why, like, I've seen this called like a gateway pattern on like .NET apps, and it's like, developers, no, bad. That's an internal API, and you're using. All right, nope, I'm not even allowed to talk about that actually. But even without explicit decoding, if the backend normalizes the URL, the traversal can land, and if the developer has decode true to get route params, the traversal is fully decoded before reaching the internal fetch. This once again opens the door for secondary context path traversal. Punctuation. Most dangerous client-side combination is VHTML with an API response that the attacker controls via CSPT. Well, actually, it would be more dangerous if they're doing it server-side and it's being handed into an eval sync, right? Because then that's RCE. But navigate to /dashboards. I guess that wouldn't really be client-side. That'd be like a secondary context path or whatever. Yeah, so it hits that and fetches the awesome attachment instead of the widget. And then it grabs the fun stuff from it that matches the form, but it has an attacker HTML that then gets rendered. So yeah. Next has a unique attack surface that no other framework shares. Island component payload revival. Okay. Oh, that sounds crazy. The revive payload client JS plugin deserializes island data from payload and fetches component data using a key from that payload. What? I would just look at this in general. If an attacker can poison the payload via cache poisoning, stored injection, or MITM in the initial HTML, the key can traverse the fetch URL to any same origin endpoint. The .json suffix gets appended, but a query parameter can absorb it, yeah, or hash, which resolves to that. This is stored CSPT. The payload is set once, and every client that loads the page fires the traversed fetch. This was assigned CVE. So, what is the CVE? Let me, okay, interesting diversion. So yeah, we've got the table, so how it's reading the data, and then which sync it's hitting, and how bad it is. The safe sources and Nuxt are route.path and full path on the client, which preserve that, and get router param without the decode option on the server. Ember sync. The primary sync in Ember is fetch in the model hook. This is the standard pattern in every Ember app. So yeah, there you go. There's an Ember route. And it's got a model, okay, and then it's doing something. Ember also has a secondary sync that's unique to its inner ecosystem. Ember data adapter is now warp drive. The adapter pattern builds API URLs from model names and IDs, and the default URL for find record does not encode. Interesting. Huh. When a route's model hook calls this .store.find user params, the decode param flows through the adapter's URL builder. This traversal payload becomes part of the fetch URL without any encoding. That's very interesting. This is an indirect CSPT sync. The developer never sanitizes fetch directly. The framework's data layer does it for them, and the adapter doesn't sanitize. Interesting. The XSS escalation in Ember uses triple curly syntax. Yeah, but when it's compiled into Glimmer, okay, we're going to talk about that. Instead of dangerously set inner HTML or VHTML, and handlebars, double curlies, escape HTML, triple curlies, render raw HTML, and production build, triple curlies compile to Glimmer VM, append HTML opcodes, which call insert adjacent HTML before end HTML on the DOM element, functionally identical to inner HTML. So there's actually some nuance here. Actually, I'll read a little bit more into this. If CSPT redirects a fetch to an attacker-controlled endpoint that returns HTML, and that HTML flows into triple curly template, true, you get XSS. The chain, query param decoded, interpolated into fetch URL, fetch hits attacker endpoint, response contains fun, triple curly's render it, script executes. Ember also has safe HTML from Ember template, which programmatically marks a string as safe for HTML rendering. Any component that wraps API response data in HTML safe before rendering in an XSS sync. Before rendering is an XSS sync when combined with CSPT. So there's actually another attack scenario here. There are certain, and I only know it from the Glimmer VM side, and I haven't looked at this in months, but there are certain ways to dynamically load Glimmer components. So I don't know what that would look like, but I know there's like Glimmer opcodes for it. And so if you control the data that's being used, or what is it called? Is it called data? I forget what the language is, but it's like the props equivalent. But if you can control the name of the resolved component, and there's a bunch of components to use as gadgets, and the data from the API response that you have a CSPT for, that could also be a very interesting way to get XSS. I've used it in the past for some crazy, very cool chains, but they weren't CSPT. They were like stored. But essentially, it could be like custom wrapper component, and you can throw a component name in there, and then it will load another Glimmer or another Ember component, which then like takes from like data dot trusted content to render, because it's like a card component, and you can also control that data from the response and then render a card component, because this component let you dynamically render a component. I've seen that behavior, and so that would be another sync where you can potentially have a lot of fun. So there's all the data there, and I've Obsidian. Yes, yeah. So transition to interesting. Yeah. What's it? Trusted append? Is that the name of the Glimmer VM? It's append HTML. Is it? I think there's like I thought for some reason, maybe in my decompiler I named it trusted append because of, I don't remember. I haven't looked at this in like over a year. The only safe source in Ember is reading the URL directly from window location.pathname or window location href, which preserves %2f decoding. Everything else flows through route recognizer's find handler for dynamic segments is fully decoded. SolidStart. Primary client-side sync is fetch and inside create resource. I need to take a reading break. Okay, trying again from SolidStart. The primary client-side sync is fetch inside create resource or create async, which are Solid's reactive data fetching primitives. Okay, great. When the tracked signal params changes via client-side navigation, fetcher re-executes immediately with no page reload. What are we doing in SolidStart, man? I don't like that level of abstraction. Okay, so it has fetch call though. For path params, this is safe. Params.userID is still encoded, so the fetch URL contains encoded characters that the server receives as is. For search params, this is not safe, so because we can have fun ones. And fetch fires with the decoded query string, yeah. SolidStart's server function at a second sync. The query API, what? Okay. With use server serializes arguments via Cerovel. Is this some weird library? I don't even trust anything to be serialized. And sends them as a post body to _server. Deserializes the exec string the client sent. No re-encoding. What? How? I want to look at that. Or actually, I don't care about this. I haven't heard of SolidStart until this. So yeah. Params.dataID came from search params decoded or a catch-all route with real slashes. The traversal string becomes the JSON RPC boundary unchanged. On the client becomes that. So is that like a JSON RPC serialization library? That okay. Which then interpolates it into an internal fetch URL. This is SSRF through a server function. Yeah, that's very interesting behavior, but I've never heard of this stack. So the XSS escalation uses Solid's native inner HTML prop unlike React's dangerous set inner HTML, which is verbose. By design to discourage use, Solid treats inner HTML as a first-class JSX attribute. I don't even know what solid is. It uses JSX. That's cool. This compiles directly to element.innerHTML.equals-value combined with CSPT via search params. If the attacker can redirect a fetch to an endpoint returning HTML, the response gets rendered into the DOM. Yeah, so classic CSPT exploitation scenario. So there's the breakdown. The safe sources in SolidStart are use params for single segment dynamic params and use location.pathname, both of which preserve percent encoding. The dangerous sources are use search params, auto-decoded by the browser API, and any value that passes through server functions that are already decoded. Conclusion. Client-side paths are a rich attack surface. Each framework parses dynamic paths and query parameters differently. There are dangerous code patterns in each framework. If a path traversal payload is passed, I'm not just going crazy, is passed to a client-side delete fetch request, it leads to CSPT. If a path traversal payload is passed to a server-side fetch request, it can lead to secondary path traversal. Yes, here we go. Path params. Does %2f decode to slash? Maybe, I don't know. What about %5c? Can I have %5c decoding to... I just feel like there's just not been enough talk about reverse solidus, especially when I'm trying to hit a fetch, where the fetch, if it gets a backslash, will normalize it to a slash. Like, what if I want a backslash? Query params decoded everywhere. Every framework decodes query parameters. There are no exceptions. Good, because that's the correct behavior. XSS syncs the escalation functions. React. Oh yeah, you should look at my table for React. It's way cooler. There's other interesting syncs you can hit. But, well, I mean, like, obviously, there's like general ones, but even there's interesting React-specific syncs you can hit, but that's a separate topic. Next.js, yeah, React. Vue Next, VHTML, Party Zone. Angular, Svelte, Ember again, yeah, I like my Ember. SolidStart, and cool. Safe sources, what won't betray you. The stuff that you shouldn't be using for this, and if you use it, you'll probably have to decode URI component to actually get the pieces of it you want out and introduce bugs yourself. This isn't a valid way to try to fix this kind of thing. Server-side, secondary, traversal syncs. I think the correct behavior is to sanitize it before it hits the sink. So when you're making that fetch with something, you need to encode this. You should and hope that this service doesn't decode paths. And if it does, double encode it. Like that. This isn't the fix, because you're still gonna have to decode stuff if you read it raw. Query params, yeah. All right. Server side, yeah. These are interesting. Very, very interesting behavior here, and finding like general gadgets for these that are framework specific and like interesting. Like, can you hit some weird underscore next thing that does something funny? I don't know. Like if you have, yeah, I don't know. That future. All right. We've hit the end of this. It is okay. We'll keep going. So yes. I have a lot of thoughts here. Very amazing research. The deep dives into why the parsers behave the way they do with certain character inputs. I wanted to see more %5c stuff. I can live without it because I love using those because they get normalized by fetch the same way that it would if you punched it into the URL bar as we saw at the top. But yes, I like this. I want to see more server-side impact or framework. If you just like dig into this with framework-specific stuff, you'll probably find framework-specific bugs that probably need to be fixed. But how can this generally be applied to bug bounty? CSPT bugs are really cool. You build your intimacy with the target application and understand its landscape. Does it have stuff that... If only there was a Chrome extension I could install to help me analyze this attack surface dynamically. Definitely plenty of great times where you're able to build like full ATO chains from bug bounty. In fact, there's a great write-up about bus factor and xssdoctor weaponizing some CSPT into XSS on a target. Why does this work? I think this explains why this works. Actually, I would say this whole write-up has been about why does this work, but for CSPT. So yeah, further research. Yeah, %5c related stuff, because like that's gonna change how the path param parsing works. Like you might be able to get those through in cases where have funky things occur that kind of like juke out some of this, and then that'll hit the fetch sync and get the same behavior. More server-side behavior. Rating. I rate this. Dude, this is exactly what like we needed here. Like CSPT is gonna be this is a game changer for CSPT, and it's gonna be taken more seriously as like putting it on the map, man. Putting it on the map. I don't know. But yeah, this is crazy. This is an amazing work from the doctor. Shout out xssdoctor. Shout out CSPT. I rate this research %2f 10 out of 10, but I sure hope that divisor between the first number and the 10 makes it through the encoding. I don't know. I expect to see some revisions to this research, so this might not be the final version of this. I have no idea if I'm going to use this footage because, yeah, it's kind of a beta draft, but this research rules, and I feel educated and like I have a much better intuition about why certain behaviors occur now. Definitely good to know why things happen. So I think this covers pieces I wanted to say on this, and one day computers will be secure, but that's because they'll be turned off.